Boys and girls, I'm Mr. Chow. Please have a look at the yellow box here on the screen. In this video clip, you will learn one of the three processes of heat transfer, which is radiation. One factor affecting radiation and three examples of application of radiation. The screen showing up here to you is exactly the same as your book. So turn to page 113 now. Prepare yourself also with a pen and write down the aim shown here anywhere on page 113. Press the pause button now to stop this video. Continue when you are done writing down the aim. Now, let us have a look at radiation. Radiation. Heat transfer through a vacuum. There is a completely empty space between the sun and the earth. This is called a vacuum. Conduction and convection cannot take place in a vacuum. So how is thermal energy transferred from the sun to the earth? We will have a look at an experiment or practical first. Practical 5.9, radiation. The aim of this experiment is to study another heat transfer process besides conduction and convection. Now, let's have a look at the experimental demonstration video.
Fix a thermometer 10 centimeters away from a filament bulb. What is the reading of the thermometer before turning on the bulb? Turn on the bulb. Wait for 20 minutes. What is the reading of the thermometer after 20 minutes? What can you tell from the result?
Answer the question now. Press the pause button now to stop this video until you are done with answering. Now here is the answer. Fix a thermometer 10 cm away from a filament bulb. What is the reading of the thermometer before turning on the bulb? (23°C). Number 2. Turn on the bulb. What is the reading of the thermometer after 20 minutes? (26°C). What can you tell from the results? The reading of the thermometer increases. This shows that thermal energy is transferred from the bulb to the thermometer. Since air is a poor conductor, thermal energy is not mainly transferred by conduction. Since the thermometer is not above the bulb, thermal energy is not mainly transferred by convection. Therefore, thermal energy is transferred by a third process. What is it? Let us continue. In practical 5.9, thermal energy is mainly transferred from the bulb to the thermometer by radiation. Radiation can occur in a vacuum and in all directions. Through radiation, thermal energy given out by the sun is transferred to the earth. A short summary. thermal energy can be transferred in a vacuum by radiation. Radiation occurs in all directions. Now we will move on to the second aim of this video lesson. We will discuss one factor affecting radiation: color and radiation. Heat transfer by radiation is affected by many factors. Let us study how the color of an object affects its heat transfer by radiation in practical 5.10. Have a look at the aim of this practical. To study how the color of an object affects its heat transfer by radiation. Let's have a look at the video demonstration first.
Plug an empty dull black flask and an empty shiny white flask using stoppers fitted with thermometers. Read the thermometers in the two flasks. Then, place a heater at the midpoint between the flasks. Wait for 10 minutes. Read the thermometers in the two flasks again after 10 minutes. Record the result in a table. Which flask is hotter after 10 minutes? Is thermal energy mainly transferred from the heater to the flask by conduction, convection or radiation? Fill a dull black flask and a shiny white flask with the same amount of hot water at the same temperature. Plug the flasks using stoppers fitted with thermometers. Read the thermometers in the two flasks. Wait for 10 minutes. Read the thermometers in the two flasks again after 10 minutes. Record the result in a table. Which flask of water is cooler after 10 minutes?
Now we will have a look at the two experiments in practical 5.10. Absorbing thermal energy by radiation. Read the thermometer in the two flasks at the beginning and after 10 minutes. Record the readings in the table below. For the dull black flask, the temperature at the beginning is 26 degrees. The temperature after 10 minutes for the dull black flask is 36 degrees. For the shiny white flask, the temperature at the beginning is also 26 degrees. The temperature after 10 minutes is 31 degrees. Which flask is hotter after 10 minutes? The dull black flask. Is thermal energy mainly transferred from the heater to the flask by conduction, convection, or radiation? Radiation. The dull black flask absorbs thermal energy faster by radiation. This is the deduction from the results of this experiment. The second experiment, giving out thermal energy by radiation. Read the thermometers in the two flasks at the beginning and after 10 minutes. Record the readings in the table below. For the Dao Black Flask, the temperature at the beginning is 80 degrees. The temperature after 10 minutes is 65 degrees. For the shiny white flask, the temperature at the beginning is also 80 degrees. The temperature after 10 minutes is 67 degrees. Which flask of water is cooler after 10 minutes? The Dao Black Flask. The Dao Black Flask gives out thermal energy faster by radiation, is what can be deduced from the result. Let's continue. An object that absorbs thermal energy by radiation is called an absorber. An object that emits, that gives out thermal energy by radiation is called a radiator. We can see in practical 5.10 that a Dao Black object is a better absorber and radiator than a shiny white object. Summary. Dull and dark colored objects are good absorber and radiator. Shiny and light colored objects are poor absorbers and radiator. Now, we will move on to the last aim of this video lesson. We will discuss 3 examples of application of radiation. Applications of radiation. Ovens. Electric ovens have heating parts inside them. Thermal energy is mainly transferred from the heating parts to the food by radiation. You can see that the inner wall of an oven is quite shiny. Otherwise, a lot of thermal energy will be absorbed by the oven instead of the food. Colors of clothes. In summer, people usually wear light-colored clothes. Since light-colored objects are poor absorbers of radiation, you feel cooler in the sun when you wear light-colored clothes than when you wear dark-colored clothes. Radiant heaters. Unlike a convection heater, a radiant heater can be installed at a certain height above the ground and can be used outdoors. It warms people by giving out thermal energy directly towards them by radiation. Have a look at this question. Can a convection heater be used outdoors? The answer is no. A convection heater warms a room because the warm air is trapped inside the room. When the heater is used outdoors, the warm air rises and leaves. Summary. We have learned one of the 3 processes of heat transfer, that is radiation. Thermal energy can be transferred in a vacuum by radiation. Radiation occurs in all directions. One factor affecting radiation. Color of an object. Dull and dark colored objects are good absorbers and radiators. Shiny and light colored objects are poor absorbers and radiators. We have also learned 3 examples of application of conduction: ovens, colors of clothes, radiant heaters. For homework, I would like you to do workbook page 56, question 7.